This is Wednesday, the 18th of December, year of our Lord 2019. 1 week from today at 9:22. Hopefully I will not be awake yet. No. It's hard not to be awake by 9:22. Even if you have older children. It's just hard to sleep in on Christmas morning. But how many people get up before 6 o'clock on Christmas morning still? On most school days, hold on. I know on most school days, but I'm talking about Christmas morning when there's no work. Do you still get up at middle school age before 6?
Oh, definitely not. Yeah, I sleep until 1. Well, let's go downstairs.
All right, we did not have homework yesterday. We spent the time doing some problem solving, right? I didn't assign any more of those, did I? All right, moving on. Listen, we're gonna open up lesson 6.2 on page 278, 279, and here we go. More algebra. Listen, if you remember these two things about algebra, I can't say it enough. This is it. Whatever they do to the letter, you do the opposite. Make sure you do the same to both sides. If you can just get that down, life would be so much easier. Now, this lesson, though, is going to keep that information. You're not really learning anything new. It's just that they're going to have something weird for you, and that is there's going to be a variable on both sides of the equal sign. Listen, that is not a big deal because you're still going to use the basic principles of algebra, those two axioms that you can add or subtract, multiply or divide, the same thing from both sides, and it'll still be an equation. You with me? We're diving right in. You can always look at those examples on page 278 and 279, but we're going to the bottom of 279, and we're going to tackle 4a plus 5 equals a plus 11, and we're just going to use what we've been using all year. The basic principles of we can add or subtract, multiply or divide, the same thing from both sides of an equation. Okay? So, ready? You got your pencil and paper ready? Let's start the family feud. Yeah.
There's a lot of water on the ground right here.
Good thing it's water, huh?
Yeah.
We'll be all right. We'll just ignore it for now, unless it starts rising. Okay? If it starts rising up over your shoe tops, let me know. 4a plus 5 equals a plus 11. If you're not with me yet, I'm at the bottom of page 279. Ready, Zacchaeus? I don't see your pencil ready to go or paper in front of you. This is a participation activity, not a spectator sport. Number 1, 4a plus 5 equals a plus 11. So the first thing you look at and don't freak out about is all the equations you've done so far, there's been a variable on one side and a constant on the other. Okay, let's keep it simple. What's the two basic principles of algebra? You can add or subtract, the same thing from both sides, it'll still be equal. Oh, one more thing. You can only combine what kind of terms? Like terms. Okay, so I can't solve for A unless I've got A on one side of the equal sign and something else on the other. Isn't after all that's what we're trying to do when we get these algebra problems? We want to know at the end of the equation, what is A? Okay, so I got to get my A's on one side. So what can I do? I got a positive 1A here. How do I get rid of it on this side? And how do I get rid of it over here? Just making sure I do the same thing to both sides of the equation. So I can't have a variable on both sides. I want to know what A is. I don't want to know what A equals A something. I want to know what A is. David, look, I'm going to subtract the A as long as I subtract the A. And where am I going to subtract the A from? The 5 or the 4A?
4A.
Because they are what kind of terms?
Like terms.
Like terms. Okay, so my new equation, my next line is going to look like this. 3a plus 5 equals 11. Stop there. What did I do? All I did was,
Oh, minus 1a.
I don't like the fact that there's a variable on each side. There's an a on each side. So guess what I can do? I'm not going like this. It's not magic. It's mathematical. I subtracted 1a over here. I subtract 1a over here. See this guy in the middle? What is he?
Equal.
What's that mean? That means
Same.
that they're the same on both sides. And if I treat them the same, they're still going to be the same on both sides. So what's 4a minus 1a? 3a. You with me so far? That's all I did. What seemed like, what? Why is there a on both sides? I got rid of it already. I'm already done with it. Now I've got a regular equation that I've been dealing with. So now what am I going to do? I still want to get the a by itself. How do I get rid of the 5? Subtract 5. Minus 5, minus 5. So my new line looks like this. 3a equals 6. You still with me? You still with me?
Sure.
All I'm doing is what we've been doing. This seems like a whole new thing. Oh, man. What's it say? Solving equations with variables on both sides. Sounds like a horror movie. For some of you it does, doesn't it? It's algebra, first of all, so it's already scary. And second, variables on both sides. Part 2. All right. So 3a equals 6. How do I get rid of the 3? What have we been doing? They multiplied a by 3, so I'm going to divide by 3. That leaves me 1a, and that leaves me a equals 2. Done.
Yay.
Am I right? What's 4 times 2? What's 8 plus 5? What's 2 plus 11?
13.
I did it right. My solution was good. Number 2, bottom of page 279. 3n plus 7 equals 2n minus 1. I hope I wrote it right out of memory. 3n plus 7 equals 2n minus 1. I can't have n's on both sides. I want to combine them. I want to get them on one side. What am I going to do, Sid? Not yet. Not dividing anything yet. I have an n over here and an n term over here, and that's no good. I want to know at the end of the day what n equals. So, nope, not yet. First thing I want to do is, listen, first thing I did here was get rid of this a on this side. It's messing everything up. I want just my a's on one side. Get rid of this guy. So how do I get rid of 2n on that side of the equal sign? Nope. I would divide by 2 to get rid of the 2. But right now, I just have 2n. So how can I get rid of the 2n? If I had 8, how would I get rid of the 8? If I had a positive 8, I would subtract 8. So I have a positive 2n. How do I get rid of it? Subtract 2n. So I subtract 2n here. And if I do it on that side of the equal sign, Noah, do I have to do it over here?
Yeah.
Do I have to?
Yes.
Why?
Because they're equal.
Because this is math.
Yeah.
And you can't just do things out of thin air, right? There's no like, hey, I got an idea, let's do this. No, it has to be scientific, it has to be true, right? So I'm going to subtract 2n from here. So my next line looks like this. n plus 7 equals negative 1. Let me stop there, and you digest that. Make sure you understand it. If you don't, I can talk about it and do it again. All I did, since I had an n on both sides of the equation, that doesn't do me any good, is I got rid of it on one side. They had a 2n, I got rid of it. Not because I felt like it, but because it makes mathematical sense. As long as I do it to both sides, they're still going to be equal. And it makes things convenient for me. Now, I can find out what n is, because it's, you know what I mean by n is, n equals? And I'm going to get n equals something, and there'll be no n on that side. Yeah. Well, we're almost done. How do I get rid of the positive 7?
You subtract 7, and then you subtract 7 from the negative 1.
Subtract
so then
7.
negative 8.
subtract 7. So over here I'm left with n equals negative 8. Wait, how do I know I'm right?
You do 3n, which would be negative 8 plus 7
Hold on.
would be negative 1.
What's 3 times negative 8?
Oh, 3 times. Okay. Then that would be negative 24.
What's negative 24 plus 7? Please, gentlemen, stop talking.
Wait a second. Negative 30. Negative 17. Yep.
What's 2 times negative 8?
Positive
2 times negative 8.
16. Negative 16.
Negative 16 minus 1.
Negative 17.
It checks out. I did it right.
Yeah, I totally did that.
All right. If you're not seeing this as clearly as looking out the left window, and it's still like looking out the right window, guess what? There's not a test on this tomorrow.
Yeah.
So we're going to number 3, and hopefully you see more clearly. There's a test tomorrow, but not on this. We started into chapter 6, just so when we pick up on January 6th, we're not like starting from scratch. We'll already have it started. But your test tomorrow, only chapter 5. If you go back to what we did at the end of last week, where you did the chapter review, and you review that tonight, you'll be ready for chapter 5 test. Chapter 5 was adding, subtracting, multiplying, and dividing fractions and decimals, rational numbers. Okay, number 3, negative 6c plus 1 equals negative 9c plus 7. So now we go to number 3, and they think, I don't know, just the way I like to think because I'm competitive, they think they're going to throw me off by making things negative. Negatives don't bother me. Fractions are numbers too, right? And negatives are numbers too. They're just as real as positives. So they don't bother me anymore. Okay, I've got a C on this side and a C on that side. That won't do. I want to know what C is. So down here, I want to know what C is, and don't tell me what C is by giving me another C term. I want to know a definite answer. I got a negative 6C here and a negative 9C there. Most of the time, Lauren, we're comfortable with our variable being on the left. So let's keep it that way. How do I get this negative 9C? How do I get rid of it on this side? And making sure I do the same to both sides. That's a good thing, Jonathan. Kiara.
You add.
Yeah. Sid, this is negative 9C. How would I undo negative 18? Add 18. So it's negative 9C, so I'm going to add 9C to both.
Add 9 sides.
Am I going to add 9C to 1? No, they're not like terms. So what do I have? What's negative 6? What's negative 6 and positive 9?
3C.
3C plus 1 equals 7. Stop, look at that. Make sure you understand it. All I did was add 9C, because I got rid of it there, just 7. 6C, negative 6C plus 9C, positive 3C. And then we just do again what we've been doing. Get rid of things till we get down to just C. How do I get rid of the positive 1?
Minus 1.
I subtract 1.
Minus 1.
So I've got 3C equals 6. How do I get rid of the 3? Divide by 3. What's 6 divided by 3?
2. C.
C equals 2. Why did I write it in blue? C equals 2. Let's check. What's negative 6 times 2? Negative 6 times 2.
Negative 12.
Negative 12. Plus what? Negative 11.
Yes.
What's negative 9 times 2? Negative 18 plus 7.
Negative 25. Yeah. That's what I meant.
It checks out. I did it right. How many have already started on number 4?
No.
Okay, keep going. $28 minus 3s. Don't like when they use S's.
Sorry.
It's so hard for me to distinguish my 5s and my S's.
So we change it to a different letter? Or you change it to S?
I'll just write it small.
It looks like 5. But like with a small lowercase I. We love you, Mr. Franklin.
All right,
Mr. Franklin, do them in cursive.
listen. True. Watch this, Cam. On this problem, I said, we're very comfortable with our variable being on the left side. It just seems normal, right? C equals something. But watch what I do here, Jonathan Mitchell. I see here that I have a negative 3s and a positive 5s, and something starts happening to my brain. I'd rather work with positive numbers than care if my variable's on the left or right. I'm actually going to do number 4 two ways. Because in all of these, we had a choice. We could have put the A on the left or the A on the right. We could have put the N on the left or the N on the right. Does it matter? 6 equals 3 plus 3 or 3 plus 3 equals 6. Does it matter which way you write it? Okay. We could have put the C's on the left or we could have put the C's on the right. We could put the S's on the left or we could put the S's on the right. I'm going to put the S's on the right. Not to throw you off, just to show you that it doesn't matter. I'll do it both ways. If I put the S's on the right, here's why I'm doing it. Because I recognize that it's going to make my S positive. Because I'm going to add 3S here to get rid of it, which means I add 3S here. So I'm left with 8S minus 12 over here and just 28 over there. Let me stop. I'm going to do it both ways. This time, Jordan, I'm making things weird by putting the S on the right. But it doesn't change anything. There's an equal sign between them. So how do I get rid of the negative 12?
You add 12.
I add 12 to both sides. That leaves me with 40 over here and 8S over there. How do I get rid of the 8?
You
It's
subtract.
S
you
times
divide-
8,
divide.
so I...
Divide by 8.
She's trying to focus. It's S times 8, so how do I get rid of the 8? Divide by 8. That leaves me with S equaling 5. Okay, now watch. Now watch this. What if has everybody got that? Take a snapshot of that in your brain, or you've written it down on paper. What answer do you think I'm going to get for S if I put the S's on the left? What do you think the answer for S is going to be if I move my S's to the left?
5.
Well, I hope you're going to say 5. This is math class. It has to be 5,
Yeah.
right?
Yeah.
So let's see how that works. Now I'm going to bring my S's over here. Ready? Minus 5S minus 5S. That leaves me with 28 minus 8S equals negative 12. Do you see why I put it on the right in the first place? I don't have to deal with all these negatives. Then what would I do? I would get rid of the 28. I would get rid of the 28 by subtracting. And that would leave me negative 8S equals negative 40. How would I get rid of the negative 8S? I would divide by,
8.
not by 8, by negative 8. That's what would give me positive 1, negative 8. Both ways, I get an answer of S equaling 5. But do you see what I chose in the beginning to put my S's on the right to keep everything positive?
No.
It doesn't matter. Either way, you still get the same answer. You like it? You just want to keep it on the left?
Yeah.
Normally I do too. So it doesn't matter which side you move your variable on, as long as you treat it the same way. number 5. Do they really think they're making things more difficult by putting the distributed property in number 5? I think they try to like give you a little more to work with each one. 4 times W minus 9 equals 7W plus 18. I'm going to erase number 1. So you better have that. Here comes number 5. 4 times W minus 9. Okay. Elise, what's that D word that I have to do when I have a value outside of parentheses? Distribute it through all the elements in there. 4 times W, 4W. 4 times negative 9.
Wait, are you actually
Negative 45.
negative 36?
Negative 36.
Oh,
Yay.
7W plus 8. Okay. So all I did from here to here, Noah, was
Isn't it
simple
18?
was work this. 4 times W, 4 times negative 9.
Isn't it 18?
Stop, wait. Sorry. You get this, Noah? Okay. Whenever there's a value written outside the parentheses, it doesn't have a plus sign, a minus sign, a division sign. What's it mean to do? Multiply when they're written right next to each other. So this, you distribute the 4 through everything inside the parentheses. 4 times W, 4W. 4 times negative 9, negative 36. You with me?
Yeah.
So this stays the same. Now we're back to our basic algebra. How do I get rid of the 36?
Plus 36.
Plus 36, plus 36. 4W equals 7W. Well, I should have done the W's first. It doesn't matter though. Plus 54. First thing I did this time was get rid of the 36s. It doesn't matter if you do get rid of the 36 first or change the W's. Now, what would you do? Move your W's to the left or your W's to the right?
Right.
To the right? You want to move to the right?
Yes.
Because that'll really complicate things.
Oh,
Watch. Because if I move them to the right, what am I going to end up with over here?
50.
A 0.
No, negative 3.
Huh?
Just keep it.
Keep it on the left?
Yeah.
Okay.
Yeah.
I'm going to keep them on the left, which means I'm getting rid of this guy. Negative 7W. Right? That's going to leave me with 54 over here. Negative 7W is negative 3W. How do I get rid of the negative 3? Divide by negative 3. $18.
Is it negative?
Listen, I could have moved my W's to the left and moved the 54 to the left, to the right, and 54 to the left. And I would have had 3W equals negative 54. Same thing, negative 18. Am I right, David? How do I check? I put negative 18 up here in the original. What's negative 18 minus 9? David. It's negative 18 degrees out and it goes down 9 degrees. What's the temperature? What's negative 18 minus 9?
Negative 18 minus 9 is negative. Oh my goodness.
What's 18 plus 9, bud?
Negative 27.
Okay.
Yes. Okay.
4 times negative 27 is negative 108. What's 7 times negative 18?
7 times negative 18. That's a
It's
good
negative
question.
126.
Negative.
Plus 18 is negative 108.
Oh yeah, I did that. Totally.
Number 6. I'm going to erase number 2. Yeah.
Oh.
That's why we're practicing, David. Number 6.
Yeah.
2 times y plus 4.
I know, so I got it. Yeah. Negative y minus 7.
Hey, stay with me here, Zacchaeus.
He's being a bully.
All right, Dominic, this doesn't bother us, does it? Noah knows that if there's a 2 written outside the parentheses, he's going to distribute that throughout, make that 2y plus 8. 2 times y, 2y, 2 times 4, positive 8. We still got negative 3y minus 7 over there. Okay, now we have a decision to make. Do we want our y terms on the right or on the left? I'm going to put them on the left because I notice it's going to make the y positive. Do you see that? No, be honest. Zacchaeus, when you look at this problem, shh, please stop. You have to make a choice here. Do you want to put your y term on the right or the left? I'm saying I'm going to put them on the left because it's going to make my y term positive. Because I'm getting rid of the negative 3y by adding 3y. So if I add 3y here, now I've got 5y plus 8 equals negative 7. Listen, when you get the hang of this, you'll start wanting to do things like this. Doing all this in one step. Like, now I know that I've got to subtract 8 from both sides, so I would have written 5y equals negative 15, but I'm not doing it that way because we're just learning. So I got negative 8 and negative 8. So now I got 5y equals negative 15. Finally, how do I get rid of the 5?
Divide by 5.
Divide by 5.
Which would be y equals negative
Y equals negative 3.
Yay!
Did I do it right?
Yes.
What's negative 3 plus 4?
Negative 3, 1.
What's 2 times 1?
2 times 1 is 2.
What's negative 3 times negative 3?
Negative 9. No, positive.
You're asking me or telling me?
Positive 9.
Negative 3 times negative 3 is positive 9 minus 7.
2.
2. I did it right.
Yeah, I forgot 2 positives make 1. 2 negatives make 1 positive for multiplying or dividing.
Okay, I know Johnny can't be here tomorrow. Sawyer and Julia, do we know if they're coming in?
Julia's coming in the morning.
Yeah.
Tuesday.
So hopefully they're here. If they're not, okay. Merry Christmas. Tomorrow is a double period and it's test day. Your test is only over chapter 5. How do you study for tomorrow's test? You go back over your chapter review and you review that. That's it. Merry Christmas.
We have no homework? We have no homework?
No.
Yay!